Hello students, and welcome to this video where our goal is to discuss the concept of scatterplots. So scatterplots are simply a graphical representation that helps to show relationships between two sets of data. So this particular image that you see on the left is showing a relationship between one person's weight and their height. Scatterplots can be very useful to display our graphical information. Because a lot of us can understand data better when it's put into a visual representation, scatters plots generally become particularly very useful. If you think about trying to begin an exercise regimen and you want to concentrate on how long do you need to exercise to lose a certain amount of weight, you could represent this data on a scatter plot and likely have a better idea of your results and how you're doing. So I have an example here. It says the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days. And so you have the temperatures, and these are in degrees Celsius, and then you have the sales. And so if I look at this, just visually looking at this table, it's a little challenging for me to make a whole lot of good assumptions, because if you notice your temperatures, they're kind of all over the place, right? And they're starting to go up, and then they go down, then they go up again, and then down again. And so, it's just a little, just kind of all over the place. And same thing with the prices. They're continually fluctuating. So to really make good conclusions by just looking at the data alone in a table format isn't very helpful to me. But when I go and put that information onto the scatter plot and noticing some things, I'm including my titles on my X and Y axis, and I have even increments on both of my axes. I'm moving in degrees of 2 degrees Celsius on my x-axis, and I'm increasing by $100 on my y-axis. When I put that information onto a scatter plot, now it becomes much more meaningful to me. So I can see that the sales, there's a steady increase as the degrees in Celsius begin to increase. So I can make more inferences about what is exactly occurring. So I would argue that for the majority of us, when we put things on graphical representation, it's much more meaningful to us. So if you think about you in a business meeting, or if you work in retail, a lot of times these companies are concerned about profit, or how much they're selling, or how much they anticipate selling in the future. And a lot of times these types of businesses want to show and offer graphical representations to their employees to make better assumptions about what needs to be done now in order to get to a certain goal. Again, these companies realize that if they show a bunch of numbers, it's not going to be super meaningful, but if they put it on a graph and represent that data graphically, it's going to be much more meaningful to an individual. And then maybe we want to take it a step further by creating what's called a line of best fit. And this is just a line on a graph showing the general direction that a group of points seems to follow. And so the idea here is, I want to create this line, and I ideally want this line to go through as many of my data points as it can. And it's very likely that it may not go through all of the points, but I would love for it to touch as many of the points as it could. So I have an example here, a scatter plot of sea level rise, and I've drawn the line of best fit, and you see there's a ton of different points, and all these different points that I have are not touching that line, but the idea is that this line is representing a good amount of those points so that it can be a good representation of predicting things in the future. So if I have a line, I can give it an equation, and if this line's a good representation of what's been occurring, then I can plug in values that represent the future. So in this particular case, I could put in future years and solve that linear equation to figure out what I think the future value will be in regards to the mean sea level. And I didn't write a slide here, so I'm going to go back for a second to the line of best fit slide. There is something called residuals. And the residual is the distance that a point is from a line. And so you measure up all these values and you add them. And that tells you your residual value. And the idea is, oh, I apologize, I had a sneeze. the idea is that you want your residuals to be very, very small. And so as you increase in upper level mathematics, there's actually different regression courses. We have linear regression and multiple regression courses that teach us about the different relationships and the idea that there's generally more than one factor that affects things. And then you start to figure out, all right, well, how would I create my best line of best fit? And then what would those residuals look like? So for example, while I'm making this video, we're currently about to face a hurricane. And so maybe I want to make a graph that represents gas prices. Well, there's a lot of things that affect gas prices, right? I would say the time of year generally affects it. Summer prices seem to go up because a lot of people are traveling, and then it may go down in seasons where people aren't traveling as much. Because we're nearing a hurricane, prices have gone up because it's a supply and demand situation. You know, there's a limited supply and demand is high, and so that could affect the gas prices. Other things are the region that you're located in. Has there been a gas link? That could affect the gas prices. So in most things in the everyday world, we want to represent things by multiple linear regressions because there's more than one factor that tends to create an effect, this cause and effect relationship on, you know, a particular situation or thing that you're looking at. So it's really interesting when you get into upper level math and start looking at these particular relationships and trying to create lines and regression formulas to represent these situations. So this brings us to another idea called correlation, and this is when two sets of data are strongly linked together, so we say they have a high correlation. Correlations can be positive, so that means two things are increasing together. Correlations can be negative, so that's when one value decreases as the other increases. So a positive correlation would be something like as the temperature increases, so as the degree, as it gets hotter outside, so temperature is increasing, the number of pool sales are increasing, right? More people are buying pools in hotter temperature months. So that would be a positive correlation because both things are growing. A negative correlation would be the more hours that I exercise, I'm going to assume my weight value is going to decrease, right? So I assume that I should be losing more and more weight the more and more I exercise, right? And this is not, I realize, not bringing in the factors of, you know, thinking about muscle mass and all these different things, but I'm just trying to take a very elementary approach to it as, you know, I believe that if I exercise more, then that results in some weight loss, right? So one thing is increasing hours of exercise, and what's decreasing is my numerical weight value. And correlations can occur in many different ways, but the thing you want to know is that they range from -1 to 1. So if I'm at -1, I have a perfect negative correlation. If I'm at +1, I have a perfect positive correlation. That means these things are absolutely perfect, completely 100% creating a wonderful line, and all your data points fall on that line. If I'm at 0, there's no correlation at all. And then you see you have your respective values in the middle that you can associate your correlations with, which help you understand, okay, you know, how strong is it? So I often hear that word used in mathematics courses, the idea of being strong. So this is strong positive correlation or a strong negative correlation. And maybe this is a medium level or low. And maybe this is a medium level or low correlation value. So going to an example of a negative correlation, birth rate versus income, the birth rate tends to be lower in richer countries, so below is a scatter plot for about 100 different countries. And so you have your yearly production per person on your x-axis, and you have your birth rate on your y-axis. And so you can see that as you increase in money value, you are lowering in the amount of birth rates that there are. So this would be a negative correlation because as one thing is increasing, the other is decreasing. Now, it's important to note that correlations do not work for nonlinear functions. The correlation calculation only works for relationships that follow a straight line. So I have another ice cream example, and I said there's been a heat wave, so it gets so hot that people aren't going near the shop and sales start dropping. So it's almost like they're increasing until a certain point, and then it just gets so hot that people are choosing to stay indoor, and so my values go back down. I apologize if you hear this noise in the background. It is my dog. dogs trying to play. And they are right on top of me, of course, while I'm trying to create a video. But as you can see in this particular example, the correlation value is now 0. There's no correlation, and we can't put a nice linear equation to this function any longer. So just important to keep in mind that you can only be working with a linear function. It's also important to note that correlation does not mean causation. So it doesn't mean, that that is a reason for something that is occurring. So our ice cream shop finds how many sunglasses were sold by a big store for each day and compares them to their ice cream sales. So although appears visually to be a positive correlation, as there's more sunglasses sold, there's more ice cream sales, that doesn't mean that there's that cause and effect relationship. Like, if I think about, is there a relationship between the number of sunglasses that the store sells and the number of ice creams that they sell? There really isn't. You can maybe stretch it and be like, it must be sunny and hot out, but that's really kind of stretching. And so just because you can put, two values that are increasing onto a graphical representation doesn't mean that there is evident correlation there. So just something to keep in mind. I hope this video was helpful to you. As always, if you have any questions or concerns, please don't hesitate to reach out.